This next example features circle U, and we are to solve the variables x, y, and z. We need to understand first what are these variables. For x, this is the inscribed angle, where the vertex here is a point in the circle and its sides are these chords. And x intercepts this arc here from this point to this point. Y is also an inscribed angle. It intercepts this arc, which measures 130 degrees. It should be the entire arc. And its sides are these chords and this chord as well. Z is also an inscribed angle. It intercepts this arc here, which also includes this small portion and this portion here. Now that we know that all of these three are inscribed angles, we need to understand the relationship of their measurements into their intercepted arcs. Please take note that the measurement of any inscribed angle is half the measurement of its intercepted arc. For this given example, we could just automatically solve variable y, for it intercepts an arc with a given measurement. But first, let me try to extend it here so that we could just separate first the other variables so that it could not complicate our process. Let us have this given figure, which is a portion of the given, where we are just removing inscribed angle z first so that we could look into the relationship between x and y that ultimately will help us later solve the variable z. Now, as mentioned, y is the inscribed angle intercepting arc 130 degrees. And we know that the measurement of an inscribed angle is half of its intercepted arc. In short, the measurement of angle y is equal to half the measurement of its intercepted arc, which measures 130 degrees. Therefore, the measurement of angle y is just equal to, again, half of 130 degrees, which is 65 degrees. So this is the value for the first variable, which is y. The next one that we could solve is for the variable x. It's also an inscribed angle. So what we need to identify right now is the measurement of its intercepted arc here. Though it's not given, we are guided by this chord here that passes through the center. And it's actually the longest chord of any circle we call diameter. This is the diameter that actually divides the entire circumference into two equal parts we call semicircle. And why do we discuss that is because the intercepted arc of inscribed angle x is from here, from this point to that point, which is the semicircle that is cut out by the diameter. We have a theorem for this, that any inscribed angle intercepting a semicircle is a right angle, because the measurement of angle x as an inscribed angle is half of its intercepted arc, we know as a semicircle, and a semicircle measures 180 degrees. So the half of 180 degrees is 90 degrees, and that's why the measurement or the inscribed angle x is a right angle. It's 90 degrees. Now that we are done with this, we could go back to our given problem, since these two are already solved, to feature or to solve the measurement of inscribed angle z. Now there are two ways to attack this problem, one of which is considering the arcs. Since this is a semicircle, that would mean the other side is also a semicircle, which measures 180 degrees. And if this is 130 degrees, we know this arc here to be something, let's say, W, when added to 130 degrees, could give us another semicircle measuring 180 degrees. So by subtraction property of equality, this arc here, though it's not what we would like to solve, but we are solving it anyway because it will help us later on solve the value of the last variable z. Okay, so we have that 180 degrees minus 130 degrees. The value of the W is equal to 50 degrees. Now, we can use the value of W here as we relate it as one of the arcs that is intercepted by inscribed angle Z. Notice that angle Z is this angle here, and the intercepted arc is this semicircle earlier, plus the newly solved arc W, which is 50 degrees. That would mean that the measurement of, let's say here, inscribed angle Z is equal to 1/2 the sum of the two arcs, which is again 180 degrees as the semicircle, plus this arc, which is 50 degrees. So we are going to add them up before we divide. So we have 1/2 of 230 degrees, and the value for the angle Z, or the measurement of angle Z, is 115 degrees. This is the value of Z here. So this is how we solve the unknown measurements for the given circle U using the concept of the semicircle, the concept of inscribed angles, and its intercepted arc.